Hi everyone! Thank you for watching another video lesson. As you know, yes. So I have a little bit of a disability here, so my handwriting is gonna not be as good, or actually just suckier, okay? Today is August 23rd or 24th, depending on when you're watching this video lesson, but it's going to be something of a review. If it's not review, I do question whether you even took geometry or algebra 1, okay? So 4.2 trigonometric functions of acute angles, right triangle, trigonometry, okay? So I want you to understand that trig has the word triangle in it. So you see a lot of triangles being attached to trigonometry, okay? Trigonometry. Now, somewhat of a review. I know that you see this right here in SohCahToa. SohCahToa, one important thing, make sure you spell it correctly, because if you don't spell it correctly, it defeats the whole purpose of SohCahToa. Another thing is, rather than remembering as SohCahToa, I know SohCahToa, I want you to remember when it's used, what kind of triangles it's used for, but also what you use it for. That's very important that you recognize that, okay? All right, let's look at part 1, SohCahToa, and more. All right, it's going to be a review, so you can actually speed up the lesson, as you know, because it's a video lesson, right? So you can go at your own pace. SohCahToa and more. You see right here, what do you see? Oh, sorry. What do you see? You see an angle in standard position. STD position. Okay, and how do we know that it's an STD position? Because you can see that its initial side is on the x-axis, and its terminal side lies along any of the quadrants, in this case 1. But actually standard position, we're going to say it's always first quadrant, okay? So these are standard position, okay? Now, here's our central angle here. And in this standard position, we can create similar triangles like this. This triangle, this triangle, this triangle, this triangle. They're all right triangles, right? Okay, we have similar triangles. What does that do for us? Well, it just creates a right triangle, all right? And we can always go back and use our sine, cosine, tangents. Maybe you guys know, but sine, cosine, tangents are only used for right triangles, okay? Now, we see a right triangle here. How do we know it's a right triangle? Right triangle always has to give you the right angle symbol, okay? So this has to be a right triangle because it has that little box. All right, this is your angle that we're referring to, and let's just put large A, large B, and large C, okay? And this angle here, let's call it alpha. So we have alpha and angle theta, okay? And obviously across the largest angle, which is the right angle in a right triangle, it's called a hypotenuse, hypotenuse, okay? And these are called just legs, right? Leg 1, leg 2, legs, okay? I'm sorry, no, it's not legs here, right? I know someone's going to correct me, so leg. Here's leg 1 and leg 2. Okay, those are just legs, okay? You know, just to practice a little bit, you know the O stands for opposite, right? Not open, sesame, or, you know, oppa. Okay, no. It stands for opposite. So if you want to write that down, make sure you write that down. Okay, the O stands for opposite. What does the A stand for? Amen? No. A stands for adjacent. So we're going to write that too. Oh, adjacent. Oh, sorry. Sorry, guys. It's hard to write, especially on the iPad, okay? Adjacent. Okay? All right. Sorry about this really terrible handwriting. Please don't show your parents, okay? Adjacent. I'll do it slower. Okay. Adjacent, okay? So, SohCahToa. And what does the S, C, and T stands for? It's all at the bottom here. But before we even do any of that, okay? Before we do any of that, if I'm pointing at angle A, okay, the opposite is going to be across, okay? Across is opposite. And the one next to it, right next to the angle, the side next to it, is going to be the adjacent. And I know some of you guys know that. That's why I told you to. You can, you know, speed up the video if you don't need to watch it. But the hypotenuse is always so golden. He's never considered, or she is never considered the opposite or the adjacent, okay? And you always, I like to give a little arrow every time I work with the angle that I'm talking about. The opposite of what angle? Adjacent of what angle, right? You can see that it's across, and you can see that it's right next to it. So those are the legs that they're talking about, okay? So to be very mathematical here, I know that you've seen this before, sine of theta. So again, go back here, sine of theta, or we can write it in many different ways. This is the abbreviation sin theta, and it's going to be opposite over hypotenuse. So, oh, opposite over adjacent, which actually spells out SOH, which is sine over opposite over hypotenuse, or SO, okay? And cosine, the abbreviation is cos theta, and we're going to write that as okay, adjacent over hypotenuse. And tangent theta, abbreviated as tan, is OA. Oh, sorry, not OW, okay? OA. And we have right next to them the reciprocal functions. Reciprocal trig functions, okay? And those are just the reciprocal of sine, cosine, tangent. So cosecant is related to sine. It's theta, which is ho, ho, ho. And we have secant theta, who is related to cosine, who's the reciprocal of. So it's going to be ha, ha, ha. And we also have cotar, or cotangent, which is the reciprocal of tangent, which is not ow. Oh, with the factor, just joking. It's ow, okay? Ow, okay? All right. Now, one note, good to know, reciprocal identities here. You're going to have to know this for later, skaters, but I don't want to keep secrets from you. Reciprocal identities here. Some notes is cotangent of x is 1 over tangent, because it's a reciprocal, and this becomes cosine over sine. And cosecant of x is 1 over sine x, or secant of x is 1 over cosine x, okay? But I think that's pretty obvious from looking at this, all right? Okay, before we take a little break, let's go ahead and see if you can actually find the sine, cosine, tangent. And I have a feeling a lot of you guys are already familiar with this, so you can actually just go ahead and do this if you want to, okay? So let's try this, okay? They want us to find the 6 trig functions of angle theta. So angle theta is here, angle theta is here, angle theta is here, okay? What I like to do with this is just put an arrow at the angle that I'm referring to, okay? And I'm going to do 6 trig functions, but I'm only going to do 3 because I think if you know sine, cosine, and tangent, then you know it's the reciprocal of these guys that you get. Secant theta. After the notes, after the video, I'm going to also share with you the transcript of my notes. So you can always, look at the notes that way too. Sine of theta is SohCahToa, right? If you still have to write this every time, go for it. Sine is opposite over Sine is opposite over hypotenuse, so you have to look opposite, across. So you get 8 over 1/13 square root of. Now, what's great about pre-cal is you don't need to rationalize, okay? So yes, if it bothers you, you can go square root of 13, square root of 113 times 3. You know how you used to do that when you were a kid? You would go, okay, I have to rationalize it. But in pre-cal, you don't have to do that anymore. You can just leave it like this. You know why? Because AP Calculus standards is what we're going to follow. And it says you don't have to rationalize it the same thing as when you rationalize, okay? Now, cosine is what? Cosine is adjacent over hypotenuse. So look at the angle is here. Adjacent is 7, right? That's the other leg that's adjacent to it. Not the hypotenuse, though. Hypotenuse is golden, okay? So we get 7 over root 113. How about tangent of theta? Wait, you know what? Let me just ask a random question. In this triangle, who is the longest side? Okay, of course, across from the right angle. The hypotenuse is always the longest, okay? And obviously this is the second longest and this is a shorty, okay? Just kind of know that, okay? Tangent of theta is what? Opposite, opposite over adjacent, so it's going to be 8 over 7. Sorry this is not lined up, so let me line it up for you, okay? Sorry. I was writing kind of bigger because of my finger, okay? All right, all good? Now, secant and cotangent is just a reciprocal of them. So I'll just start you off. Root 113 over 8. Root 113, I'll just finish it. And 7 over 8. All right? Okay, let's go. Now, I think one question that I can ask you about sine, cosine, tangent is this. Which of the trig functions has to be sometimes could be, which of the trig functions has to be less than 1, and which trig function does not have to be less than 1 always? Okay, think about that. Okay, number 15. And these are questions from your homework, okay, guys? These are all questions straight out of your homework. So when you're working on your homework, you can see, oh, number 2. If you're stuck on number 3, look at the example for number 2. If you're stuck on number 14 or 16, look at the example for number 15, okay? This is the last example for part 1, all right? So get excited. Assume that theta is an acute angle in a right triangle satisfying the given conditions. The given conditions are here, okay? Evaluate the remaining trig functions. So there's 5 that we need to find, right? I think the easiest way to attack something like this is either 1, sketch it. Actually, there's only 1. Sketch it, sketch it, sketch it. Okay, you could either sketch it on a standard, you know what? Let's actually sketch it on a standard position. Okay, we have standard position here. Okay, cotangent is, let's just draw a right triangle. And let's make this guy theta. Let's sketch it. Sketching doesn't take that long, okay? And sketching is going to help you to not miss the question completely, right? So sketch it. Cotangent is what? Well, if cotangent is 11 over 3, that, I hope you're processing this as tangent is 3 over 11. It isn't tangent TOA. So isn't this O and A? So opposite of adjacent. So let's actually mark that on our beautiful diagram, right? O, opposite of this angle is 3. Adjacent is 11. I think that's the first thing we can do. So first thing is a sketch. Second thing is to conclude that if you know cotangent, then you also know tangent. And then I think you should label it third, okay? What's the fourth thing? Well, okay, if you know it, go ahead and try it. But I think you're thinking, well, in order for me to find sine of theta, cosine of theta, tangent of theta, and secant of theta, right? Because we already know a lot of these. And cotangent of theta, right? We have to know sine, opposite, adjacent, and the hypotenuse, right? So we got to find all that, okay? So let's go ahead and find. But what do we need? We need the hypotenuse, right? So what do we need the hypotenuse? How do we find the hypotenuse? We take the opposite. We do Pythagorean theorem, sorry. 3.5, step 3.5. Pythagorean theorem, okay? All right, Pythagorean theorem says leg squared plus leg squared equals hypo squared. What's the leg? 1. So it's going to be 3 squared plus 11 squared equals hypo squared. Okay? All right. So chicos, I'm going to actually cut this guy here and move it down a little bit. Okay? Oh, not that far down. Okay? All right. When you calculate this, here's what I get. I did the math for you. 130 is equal to hypo squared. So that means the h is going to equal square root of 130. Just leave it as square root of 130, okay? So I'm going to write that also on the triangle itself. And that should help you get the rest. Okay? I won't finish because you should be able to finish that. Good luck, and make sure you watch part 2, or you can go ahead and try this homework right here, right now. Okay? Bye!